Energy is derived from a Greek word energia, which is being at work. Aristotle defined energy as a condition that describes the capacity to do work. There are different forms of energies in the nature. For example, mechanical, heat, light, chemical, sound, magnetic, electrical, atomic, etc. The energy is in everything, but we obtain usable energy from particular sources. Source is a thing which provides something. Here we'll be discussing about various sources of energy. There can be various ways in which we can classify sources of energy. Sources of energy can be renewable or non-renewable. They can also be conventional or non-conventional. Renewable. Renewable sources are in very large quantity and can be used again and again. If some are not in large amount, then they could be produced fairly quickly. So either they are in large quantity or can be produced quickly. Example: solar energy, wind energy, geothermal energy, water energy, ocean energy, etc. They all are in large amount. And biomass energy, it can be produced fairly quickly. Non-renewable energy, they are in less quantity and take a lot of time to be regenerated. For example, coal, oil, natural gas, etc. Conventional sources, sources which are in use from a very long time. They are used extensively. For example, fossil fuels, hydro energy, biomass, wind energy, etc. Non-conventional energy sources, they are not used extensively, and the technology to use them is developed not far long ago. Example: solar, wind, ocean, geothermal, nuclear, etc. As discussed above, there are so many different sources of energy. All of them have some merits and demerits. Here is a list of qualities that a good source of energy must have. First, calorific value. It is the amount of heat which is given out on full burning of a unit mass or volume of fuel. Generally, we take 1 kg as the standard. We want the calorific value to be as high as possible because the more the energy obtained from the fuel, better it will be. Optimum ignition temperature. Ignition temperature is the minimum temperature at which any substance catch fires or it starts to burn. Obviously, if the ignition temperature will be less, then the object will catch fire even at the room temperature. And if it is more, then we will require to spend a lot of energy to make it burn. Therefore, ignition temperature should be optimum. It should not be much higher and it should not be much less. Third, it should be easy and convenient to handle, store and transport from one place to another place. Fourth, it should be affordable and should be easily available. Fifth, it should produce as less pollution as possible. It is a very important point because today climate change is a big issue. Sixth, the burning should be complete and residue should be as less as possible. Obviously, in most cases, it is not possible that one fuel possesses all of these qualities. For example, petroleum is cheap and easy to use but cause a lot of pollution. So we have to sacrifice on some points. Now we will discuss various sources one by one. First, fossil fuels. Let's first discuss what are fossils. Have you seen photographs like this or this? Have you wondered what are these? These are the fossilized living organisms. Why do they look like this? It's because they have been processed under intense pressure. Fossils are the remains of the dead and decaying animals, which are pressurized by the Earth's crust. When these fossils convert into fuel, they are called fossil fuels. This process takes millions of years. The most widely used fossil fuels are coal, petroleum, and natural gas. Coal. It is of various varieties. It may be a mixture of carbon, hydrogen, oxygen, nitrogen, and sulfur. Carbon is the central or essential element of coal. It was formed by the thermal degradation of the wood of trees which got buried in earth millions of years ago. Coal is of various types: pit, lignite, bituminous, anthracite. We differentiate them on the basis of the amount of carbon present in them. Petroleum. Petro means rocks and oleum means oil. It is a crude oil. It is formed due to the decomposition of age-old vegetation and animals under high pressure and temperature in the absence of air. Petroleum consists of petrol, diesel, petroleum gas, kerosene, grease, petroleum jelly, paraffin wax, lubricating oil, fuel oil, etc. Top 4 are used as fuels. We know the use of petrol, diesel and kerosene. Let's discuss about LPG, liquefied petroleum gas. It is mainly composed of butane, C4H10, with small amount of ethane and propane. The working of LPG cylinder is quite interesting. To understand it, let me ask you a question. When we switch on the gas stove, then the LPG coming out of the nozzle is burned. But then why doesn't the fire reach the inside of the gas pipe, or for that matter inside the cylinder? For understanding it, let's see how combustion works. Combustion or fire requires 3 things: oxygen, fuel and spark. In the case of LPG cylinder, there is fuel, that is the LPG gas, and spark, which is provided by you. But there is no oxygen inside the cylinder or the pipe. The gas butane is coming out with high pressure from the cylinder. Therefore, the atmospheric oxygen cannot reach the inside of the pipe or cylinder. Another funny thing is that butane is odorless, but there is very distinctive and unpleasant smell when the gas is leaking. It is because we have put a gas ethyl mercaptan in it just for the safety purpose. This gas is very foul smelling. Natural gas. It mainly consists of CH4, that is methane, occurring deep inside the earth's surface. It is either alone or along with crude oil. Commercially, the gas is used as CNG, compressed natural gas. CNG is less polluting than petrol or diesel. You must have seen auto rickshaws or vehicles running on CNG around you. The next main source of energy is hydro energy. Hydro, which is related to water. So hydro energy is the energy which is obtained from water. When the water is flowing, it has kinetic energy, and when it is falling from a height, it has potential energy. These energies can be used to rotate the turbine, which can produce electricity. As you can see in the diagram, the water flowing with high velocity is rotating the turbine, and that turbine in turn helps the generator to produce electricity. Next is the wind energy. The principle is same here. There is a turbine which is rotated by the wind, and that turbine helps the generator to produce electricity. Next is biomass. The biogas CH4 is produced due to the decomposition of cattle dung and other bio-waste in the absence of oxygen. CH4 is then used as fuel in vehicles and other places. The slurry which is left behind is used by the farmers as manure for the fertilization purpose. Next is solar energy. Sun is the ultimate source of energy. The plants obtain the food from photosynthesis. Then the plants are eaten by other organisms. Without sun, life would have been impossible. Earth receives approximately 1.36 kJ per second per square meter of energy. But this entire energy doesn't reach Earth. About 40% of this energy is reflected by the atmosphere into space. Some is absorbed by gas and particles present in the atmosphere. Only about 47% of the incident energy reach Earth's surface. Solar energy is non-conventional energy source. This might be counterintuitive because we have been using solar energy since time immemorial. Sunlight was and still used for drying clothes grains, producing salt, etc. But what we are concerned about here is the production of electricity. Solar energy was not previously used for producing electricity. That's why we are calling it a non-conventional energy source. There are various solar devices used for various purposes. For example, solar cooker, solar cell, etc. We will discuss about solar cell here. It is a device that converts solar energy into electrical energy. At this level, you might not understand the concept of semiconductors, but just keep in mind that their conductivity is more than the insulators but less than the conductors. So, solar cell is a p-n junction semiconducting device which produces electricity. When the sunlight falls on solar cell, the charged particles of p-n junction diode get the energy and become free, and so the charge starts to flow and electricity is produced. Solar panel. When solar cells are arranged adjacent to each other or side by side, it is called a solar panel.